Hi, everyone. My name is Igor. I work on AI data processing team at Google, working on Grain. Grain is a data loading framework for JAX training and evaluation. So several main features that it was designed in mind are, first of all, it should be flexible. It supports any Python level record transformations, and it supports some advanced dataset transformations, as in like global shuffling, even like when the whole dataset doesn't fit into memory and things like that. Another feature is it's deterministic by default. So it provides a seed management mechanism so that when you run the same pipeline multiple times, seeded the same way, you will get the same results. We think this is important for reproducible training. Another part, any non-trivial scale training will hit either hardware failures or preemptions or some sort of failure like during its training. And Grain handles checkpointing alongside the model, and the checkpointing mechanism is efficient. And last but not the least, it's performant. It uses a combination of multi-threading and multi-processing to distribute the execution of the pipeline so that the training itself, the accelerator, is not starved for data. All right, this is what a typical LLM pipeline with Grain would look like. You start with multiple sources, then you apply tokenization, you add some metadata for later analysis, you do a global shuffle like within each of these data sets, then you repeat them for multi-epoch training, and then you mix these data sets with some proportions. After that, typically, if you start with text data, they all have different length, and you will probably want to feed them into the same length. And like instead of padding, you would use some sort of packing algorithm to do that. And lastly, you would batch them and distribute across multiple processes to parallelize the computation. So this all would typically run on the host, and then in the end, you have your training step. You allocate the data wherever you want and run the training. It's well integrated with the external ecosystem and some data source solutions outside of Google, like including Hugging Face datasets, PyTorch, and TensorFlow datasets, obviously. Or alternatively, you can use data in one of the your own data in one of the supported formats. And we strongly recommend array record format because of the support for efficient random access, and that allows things like global shuffling, global index shuffling, and efficient checkpointing. And the data can be either on remote storage or local storage. Yeah, to give you some idea of like the things that we're working on right now and planning to work on in the future, it's like the smaller things like the documentation, some particular performance improvements that we're working on, and the tooling for people to debug performance. Because, well, when you do training, the last thing that you want is for your accelerator to be bottlenecked by the data and like be underutilized. And we're trying to help prevent that from happening. And for some long-term features that we're working on is this horizontal scaling solution that basically allows you to offload the data processing from the accelerator host to a set of remote workers to then send it to the right devices. And another one is this ability to share transformation during training and serving to prevent the training servants queue. Right, that's all for me. I'm going to be present at the roundtable discussion, so that's going to be a good place to ask questions if you have any, or feel free to find me in the room. Right, thank you.